Alright, can you see my screen, right?
Yes, sir.
Alright, let's start. So let's say I have a car wheel. Actually, I'm going to draw over here. Let's say this is the wheel of car, and this car wheel, actually I'm going to try to draw. It's not exact that way. So try to understand this wheel of a car. So there is, this is the center of this wheel of car, so this wheel of car is rolling towards that direction with some angular velocity, because there is a force actually, that 10 Newton force apply on that system, which is over here. Due to this 10 Newton force, actually this wheel is moving towards forward direction, and they give us the radius of this wheel is r, which is given r actually 0.3 meter. And the mass of this wheel is 10 kg, and due to that force the system accelerated at a rate, or the wheel of this car actually they accelerated at a rate which is a is 0.6 meter per second square. So now the question they ask you, the two questions they ask you, first question is what is that frictional force acting on this wheel, because this surface is frictional. Second one, what is that rotational inertia of this wheel? Do you understand the question? Because it's a wheel of a car actually that rotating due to the 10 Newton force we apply, and is moving towards forward direction with the acceleration 0.6 meter per second square. The mass of this wheel actually the 10 kg, and the radius of this wheel actually that 0.3 meter. Now since this wheel of car actually there will be also a frame actually, because it's not totally look like actually that cylinder or disc actually, I'm sorry, not the cylinder, it's look like something that actually. Now if I want to find out the frictional force, I need to draw the free body diagram. If I draw the free body diagram, then I will find out the forces actually acting on that. This would be my mg, is the force is mg. This is the 10 Newton force, that's fine, is dragging on that. This is actually that normal force. I think I use red color, and this is to be basically frictional force toward that direction, right? It's not a Fs, it's only right down there. F frictional force is a kinetic frictional force will be over here. Fine. So these are actually the free body diagram. That's mean the four force actually acting on there. One is actually the applied force 10 Newton force. Another actually that weight, which is mg normal reaction force, and the frictional force. They are asking to find out this frictional force over here. This is not Fs. It should be only the F. Fine. So if I want to find out that frictional force, so what I can do actually, I will take this is my reference axis. I'll write down net force along to the x direction must be equal to ma, right? Because it's moving towards that direction with the acceleration 0.6 meter per second square. That's given. So I know there are two forces actually acting on this wheel, which is 10 Newton towards the positive x direction and frictional force towards the negative x direction, right? So then I'll write down the 10 minus F must be equal to ma. I know the mass and I know that acceleration of the system. Then I'll be able to find out F should be basically, which is we are looking for in the first question, it should be 10 minus ma. That's going to be the 10 minus mass is also 10 kg into 0.6, which means 10 minus, that will be the 6. It would be simply the 4 Newton. That will be the frictional force acting on this wheel when it's moving. This is the answer to the first question. Second one, they asked me to find out that moment of inertia of this system. Look, this is not actually, I know this wheel actually the rotating about is center of mass, but it's not look like a disc, right? If you because disc is basically a continuous surface, there will be no gap into the disc, right? But in the case of wheel, you will find out it is not a continuous surface. You will find out some portion, this is actually look like that, right? If you closely observe that wheel of a car, this portion actually the vacant, this one. So that's why I cannot say the moment of inertia for wheel of car would be basically the moment of inertia of a disc. I cannot say that, and I'm not going to find out all because this is a complex system actually. You have some that masses of this wheel actually also, that portion also has a mass. The total mass of this system actually the 10 kg. So that's why it's not too easy to integrate that to find out that moment of inertia of the system. But there is a way we can find out. I know there is a relation between that torque and also the angular acceleration. Torque actually, which is I alpha, which is the, I said that this is actually the Newton's second law in terms of rotation, right, in the previous class. This is tau actually the torque, I actually the moment of inertia, and alpha is the angular acceleration. I know the linear acceleration of a system, which is a, that's given actually 0.6, and I also know that there is excuse me, excuse me, there is a relation between the linear acceleration and the angular acceleration, right? What was that? Can anyone tell me? What is the relation between the linear acceleration and angular acceleration? You can find out, if you forget about, you can find out from easily from that relation, v equal to omega r. If you take that derivative, it should be dv over dt, d omega over dt. R is fixed, you are not changing that radius. Then a would be basically that alpha r. This is the relation between that angular acceleration and the linear acceleration. I know the a. I also know that r, which is the radius of this wheel. Then I will be able to find out that alpha. If I know the alpha into that equation, and if I also know that torque, then I will be able to find out this moment of inertia. That's the second question they are asking to find out. All right. Then first of all, I will calculate the torque of that system. Torque. I know the torque we can find out using that formula tau actually that r cross f, right? It's never f cross r, or simply you can find the magnitude actually r f sine theta. And the convention I said, I will consider the counterclockwise torque is positive, and if it is the clockwise, I will take it with a negative. We will find out, or we will also follow that convention over here. Fine. To find out the torque, I have to actually find out the torque for every single forces acting on that system. Look at this. If you look at the free body diagram over here, there are 4 forces actually acting on this system. One is actually the 10 Newton, one is the normal reaction force, one is actually that weight, another is actually the frictional force, right? Then I will calculate the torque of this system actually. I will try to find out the torque of this system, since I am looking for find out the moment of inertia for this system about the center of mass. Then I will also consider for this system the torque about the center of mass, because it is rotating about this point actually. So that's why I will also calculate the torque about this point, which is actually that center of mass of this system. Alright, so if I calculate the torque, then I have to consider all the 4 forces say acting on that system about that point. Let's say write down the torque for first one. I'm writing these torques basically. So torque, look at this. If you consider the torque, calculate the torque for 10 Newton force, what should be the torque? Can anyone tell me? If I only calculated the torque for 10 Newton, what should be that? What it should be if I calculate the torque for 10 Newton about this point? What should be the value of the torque? Hello, can you hear me, guys?
Yes, sir.
Can anyone tell me what should be the value of the torque about this point only for 10 Newton force? Hello, can anyone tell me?
Sir, which formula should we use?
Torque, this formula. We have only one formula to calculate the torque. Torque tau actually the r cross f.
The value of
Sir, 3.
theta value কি 90 হবে?
Theta value would be 90.
তাহলে স্যার 3 হবে।
How?
আর 0.3
আর হচ্ছে 0.3 আর f 10, তাহলে sin 90 হচ্ছে 1, তো 0.3 আর into 10 হচ্ছে 3।
All right. So remember, that's why I'm asking you whether you understand this formula to calculate the torque properly. So remember, when you are going to calculate the torque using that formula, I said this one in the previous class, r f sine theta, right? This is actually that point actually where you are applying the torque. That's very important. And which point actually you are calculating the torque. Where you are applying the force and which direction you are applying that force. That is also important, right? I said the 2 point is very important to calculate the torque. So where you are applying the force and at which point you are going to calculate the torque over here. So when you go you are going to calculate the torque of these discs about this point, and the force is also acting over here 10 Newton, right? What is the value of r in that case? What is the value of r right now? Hmm?
0.3.
0.3 to
0.3 is where? What is the radius over here? Are we applying the force over here? Are we applying the 10 Newton force over here at a 0.3 distance? Where you are applying the force? Still you are not getting my
স্যার
point.
টর্কের ভ্যালু 0 আসবে
Of course it would be 0.
সেন্টারে এটার ফোর্স অ্যাপ্লাই করা হয়েছে
Exactly, because R is 0, I am applying the force 10 Newton over here, right? But these are actually, I'm saying that the position of the force where you are applying the force from your rotational point. That's one I said in the previous class. Probably you didn't go through that topics. So that's why the torque would be 0 over here for 10 Newton force. By that analogy, if I write down, I'll write down simply this equation. Say 10 into 0, I'll write, this is the 10 for 10 Newton force. And let's draw the free body diagram again over here. Then it would be easier for you, I think. This is the 10 Newton force. This is my mg. This is my normal reaction force, and this is my frictional force. Right, so that's it. For 10 Newton is going to be the 0 plus mg, that would be also 0 because mg also acting at the center, plus normal reaction force would be also the 0. Right, and for Fs, I'll find out some torque over here because the Fs actually acting at that surface which is at a distance of radius, which is the r over here, and due to that torque the system will try to rotate in that direction, which is actually that clockwise direction. I will say this will be the minus over here, minus F, this is F only, not say the Fs actually, F the frictional force into the distance is r, and what is the angle over here? It's a 90 degree, right, between that your radius and your force. This angle is 90 degree, and sin 90 actually the 1. I drop that 1. I give the minus sign because the system will be moved in that clockwise direction. So then I'll simply find out this torque is going to be that basically minus F into R, and I know that one, which is F is 4 and R is 0.3, is going to be basically minus 1.2 Newton meter. That's the unit of this torque. Fine. So if I know the torque, then I'll be able to find out basically moment of inertia using that formula, which it should be, torque should be that I alpha. So I'm going to find out that I, it should be torque divided by alpha. So alpha I can find out because A is actually that alpha R, then alpha would be A by R actually. Let's plug in those values, or I can drop this one. Torque would be, I take the magnitude of the torque, it's a negative actually, it's meaning the direction it will take actually. So if you simply write down F into R, and alpha should be A by R, right, then if you plug in those values you will find out that the torque moment of inertia for this system is going to be that 0.6 kg meter square. So that should be that moment of inertia for this wheel of car. This is the answer. So that's why when you're going to calculate the torque, you have to think in that way, where you are applying the force and through which point actually you are going to calculate the torque. It is very important to calculate the torque.
স্যার
Yes.
স্যার একটু পেজটা একটু উপরে উঠাবেন, একটু দেখা যাচ্ছিল।
স্যার একটা কেস দেখালেন না r equal to 0 হবে, ওটা আরেকবার বোঝাবেন?
So R is 0 for 10 Newton force over here because the torque we are going to calculate using that formula R F sine theta, right? this formula I said in the previous class, R is the actually that position of force from your rotational axis, or sometimes we say this is actually the lever arm. So that's mean where you are applying the force from your rotational axis. For this wheel is rotating about this point, which is the center of mass, and I also apply the force is at that center of mass. Then what would be the value of R? Your force and your center of mass at the same point, so that's why R is 0. For mg it is
Okay.
mg is also the 0. For the normal reaction force, also the normal reaction force is acting over here, but the angle is basically right now it is also passing through the origin. The angle is basically 0 degree, and the sine 0 is 0. So that's why for the contribution for the normal force is also the 0. We only find out the torque for this frictional force. All right.
Okay, sir.
All right, let's say there is a wall. That wall there is a ladder actually inclined in that way. A person actually standing on that ladder. I'm going to move to the upward direction. So, or standing actually over there. This ladder create a angle over here which is 50 degree. They give us the length of this ladder actually 8 meter. So that's mean this total length from here to here is the 8 meter. The weight of this ladder, I'm writing WL, which is the weight of this ladder actually 355 Newton. Sorry, 355 Newton, and the weight of this person, so the person actually the 875 Newton. So he is standing at a distance 6.3 meter from this bottom point actually. So that's mean this distance from here to here actually x. Alright, so they asked me to calculate the forces actually acting on this ladder by the ground. How many forces actually acting on this ladder provided by the ground? So I have to calculate that part actually. So can you tell me actually how many force would be over here acting? Just the number. Because I need to draw the free body diagram over here if I want to find out that forces and also provided by the wall actually we'll find out there will be force. Let's say generally, can you tell me how many force will be acting over here? Just simply the number.
4.
4 force. All right. So is there any other forces? Someone says force. Yeah. Is there any other opinion? All right. It's right. It's a 4 force actually. Can you tell me the name of this force right now? You're right, there will be 4 forces actually over here. Let's say one force actually the weight of this person, right? Which is actually, I'm writing that weight of this person, this is one force. Another force, the weight of this ladder, which should be at the mid of this ladder actually, that's I'm going to draw over here, which would be basically weight of this ladder. Fine. What are the other two actually? One force will be provided by the ground, and one force will be provided by also that wall. Now what should be that direction actually? Since this ladder is going to be the apply force into that direction, so wall will also provide a opposite force towards in this direction, right? So this is, that's why this will be the force provided by the wall. Let's say this is actually P, the force on that ladder provided by the wall. Now what about the ground? Ground will give you actually that, which is actually I can say the normal reaction force actually. One force will be provided by this direction. This is the normal reaction force actually. I say that ground force, right? And there will be one more force actually, which is frictional force also acting on this ladder, because if there is not enough friction into the surface, yeah, there will be also the friction for this wall. Let's say we are neglecting that part actually, we are considering the friction only on the ground. So if the friction is absent, then this ladder will try to move towards in that direction, in the backward direction, right? In that direction, it will try to move in that direction actually, if there is not friction, because it's going to slip down. So that's why the ground will try to resist that motion. It means that it will give a force in the opposite direction of its movement. So then this force or the frictional force should be that direction actually. Do you understand? Let's say this is the force by the friction actually over here. I'm going to find out these forces over here. Do you understand the free body diagram?
স্যার ফ্রিকশনাল ফোর্সটা বুঝিনি।
So if there is not friction into the surface, because otherwise if there is not friction, this ladder will be slide to the downward direction. That's mean this side will move to that direction and this one will move to the downward direction, right? That will be happen actually, it will be slip downward actually. So to resist that motion, surface or the ground will provide a force. Since it's trying to move toward that direction, the ground will give it a force in the opposite direction to resist that motion. So that's why I'm saying that this would be basically the frictional force provided by the ground onto that ladder. Do you understand right now? All right.
জি
So
স্যার।
now I'm going to calculate these forces actually over here, these normal reaction force, or you can use the normal force actually. Any symbol you can use. Fine. So I'm going to find out these forces over here. To find out, since this ladder is static equilibrium. Static equilibrium means it's not moving, right? For what was the condition for static equilibrium? I said in the previous class there must be two conditions. One is the net force on the system must be equal to the 0, and second condition was the net torque on the system must also be the 0. This is actually for condition for the static equilibrium of a system. All right. So if I take the first condition over here, let's choose, this is my positive x, this is my positive x axis, and this is my positive y axis. If it's right, then I will also split my this axis over here. So that's mean I will can write the net force along to the x axis would be 0, and net force along to the y axis would be also the 0. Right? Can you write this one?
Yes, sir.
Fine. So first one, then I will write down. Let's say for the first condition, net force along to the x-axis is 0. Then what are the force along to the x direction over here?
Sir,
Yes.
sir, sir, net torque এর ভ্যালু 0 কিভাবে আসলো?
I cannot hear you.
স্যার টর্কের ভ্যালু 0 কিভাবে আসলো?
Oh, so it said.
স্যার টর্কের ভ্যালু 0 কিভাবে আসলো?
So since it is static equilibrium, is the ladder is not moving, right? When you place a ladder against a wall, it's not moving. It's not moving at all, actually, right? That was our intention, so that we can do some work. If the ladder is going to the move, I cannot do that work, or you cannot do the work. So that's mean when you place the ladder against a wall, it's not moving. Then I can say it is also not rotating, actually. So that's why I can say it would be totally static equilibrium. And this is the condition for static equilibrium. I said in the previous class, actually, right? Did I say that one? Probably. I said, let's look at that condition I write for you. Didn't I say that one in your class? Oh, torque, I talk about the torque, that's fine. Oh yes, I'm sorry, I didn't talk to that part actually in your class. Oh no. Alright, so yeah, that's why you're asking that question. I'm sorry, I didn't talk about that part. Alright, so I'll come to back over here. So before that, I need to give you that idea actually. In the previous class, I'm sorry, I'm extremely sorry. I'm sorry for that one. Fine, so I'm going to talk about that part actually. Let's say we defined that angular momentum was actually r cross p, right? That's the definition of the angular
sir.
momentum. Now let's take derivative of that function dl over dt. If I write, then I'll find out this would be dv over dt r cross p. And I can write one more line over here. Let's say this is the dl over dt, so which is r into dt. So this p I can also write down m into v. It's a linear momentum of the system, right? So then dl over dt I'm going to write actually. So I'm going to apply this dr uv formula. Dr over dt I'll keep m into v. So that's when I'm taking the derivative of the first function, taking the second function intact, plus in the second case I'll take the derivative of the second function keeping the first function intact. So that's why I'm writing that this is r cross m into dv over dt. Since m is a constant, so that's why if I take the derivative of m, this will give me basically the 0. Fine. So let's write down dl over dt actually. So what will give me dr over dt? Rate of change of position with respect to the time. What it would be?
Velocity.
It's a velocity, exactly. V cross m into v plus r cross, and dv over dt would be acceleration, right? So
Yes,
then
sir.
I'm going to write dl over dt is going to be the, I can factor out this m. This is a scalar number. So v cross v plus r cross. This is force, right? Simply the F over here. Now what should be the value of v cross v?
Zero.
It should be 0, right? Because angle is 0. So that's why I can write this is going to be 0. I'll simply find out it should be r cross f, and r cross f is simply what? Which is that? Torque.
Torque.
Right. Then we can write down the torque. Net torque would basically, so del L over dt, or simply you can write down that del L over del T. So that's when if you want to change the angular momentum of a system, you have to apply the torque on a system. It look like the same we talk about in the linear momentum. If you want to change that linear momentum of a system, you have to apply a external force onto that system, right? Exactly the same case. So let's say if I say, this is a vector actually, let's say if I say if that torque is 0 on the system, then what I can write? I can write actually that del L would be basically the 0, right? So del L simply that change of angular momentum final minus angular momentum initial. So then I can write actually, so Li should be Lf, which is actually that linear angular momentum must be actually that final angular momentum, provided if the torque on the system is 0. And sometime we will be also able to write out, since this angular momentum for we can write is a I omega. So let's say this is initial angular momentum, this is initial angular velocity, it should be if into omega f. So this is actually known as conservation of angular momentum. Just we write. So when the torque is 0, there is two conditions actually to say that if the net force is 0 on the system, then the system center of mass cannot be moved, right? Let's say this is my disc. If the net force 0, this center of mass cannot be moved. So that means there will be no velocity towards that movement of the center of mass, but it can be rotate about this axis. In that case, is center of mass not moving, but it can be rotate about this point, right? Which would be simply that rotational motion. But if you say that net torque on the system is 0, then it cannot be also rotate. In that sense, I will say that the system will be totally static. It cannot be rotate, it cannot be moved. So that's why this is the condition we say that is static equilibrium. When the net force and the net torque is 0 on a system, that system would be totally static. That's why the condition for the static equilibrium is should be net force should be 0 and the net torque would be also the 0 on the system. All right, you understand that part? I'm sorry, I missed that part actually in your section. I talk about this part actually, that another section. Using that one, I'm going to solve this part actually. Let's make it copy from here. Oh, understand. So that's why I'm saying that since this ladder actually it's not moving, also it's not rotating. So that's why it would be static equilibrium, and condition for the static equilibrium is net force 0 and the net torque would be also the 0 on the system. Using this idea, I will find out these forces G, F and also the P from here actually. So if I choose that part actually, what I can say, let's look it over here actually. So I write down the net force 0. It means that net force along to the x-axis would be 0 and net force along to the y-axis would be also the 0. Then what are the forces along to the x direction? I can write simply it should be
F minus P.
F minus P, exactly. So this would be F minus P would be equal to the 0, right? This is the first condition. So that means I can also say that F would be basically the P. I have to use this equation. Let's keep it in that way. Fine. Now write down the net force along to the y-axis is 0. Right? Now what will be happen in the case of y-axis? There are three forces from this free body diagram. One is G, which is the upward, downward is WL, and there is one more weight by the person, which is WP. I know these two, WL and the WP, right? So then it would be easier for me to find out G would be WL plus WP. Simply if you add these two one, which is 355 plus 875, that will give you actually 1230 newtons. So this is would be that normal reaction force provided by the ground, which is would be 1230 newton. This is that one answer. Fine. I need to also find out these reaction forces. Both are frictional forces, and this is also, I can say, the normal reaction force provided by this wall on that, which is P actually right over here. I have to also find out F and P. If I can find out any one, I'll be able to find out the other one, because he said that F actually would be equal to the P. All right, to find out that one, I will apply the torque, the second condition about this point A, which is that one. I will calculate the torque about this point for every single force. For this, how many force? 1, 2, 3, 4, 5. There are 5 force over here. Fine. So I'm going to calculate the torque. So I know that torque, net torque for this system must be equal to the 0 over here, and I'm considering the counterclockwise rotation actually the positive for these forces actually. All right. So if I calculate the torque about this point A, the contribution for the force G and the F would be 0, right? Are you agree with me? The contribution of the torque in the torque provided by the force G and the F would be 0, right? Do you understand that part?
No, sir.
Why it would be the 0? Because we are using that formula, torque actually that RF sine theta. I'm considering the torque about this point, and these two forces also acting on that point. That's why the R is 0 for F and also the G. If R is 0, the torque would be 0 for these two forces F and G. But I will find out the torque for this force, which is WL, because this is acting at a distance R over here, and I will also find out the torque for this WP, that is acting at a distance X, and I will also find out the torque for P, which is acting at a distance length of this ladder. I can find out that one, right? Fine. But for that one, I need to actually find out the angle of this system actually. Let's find out that angle actually first. So what should be that angle? This angle and this angle would be equal, right?
Yes, sir.
What would be that angle? Can anyone tell me what should be that angle?
Forty.
40 degree.
40.
Exactly, it should be the 40. Because if you extend that one, this is 50, this would be that 90 over here. If you extend this would be the 90, then definitely this is going to be that 40. If it is 40, this would be 40. What would be that one?
50.
It should be
50.
50, because this is the alternative angle, right? This is going to be that 50 over here. All right, just find out. I find out the angle for all these forces. Then if I calculate the torque, look at this. The torque will be negative for these forces because it is moving to the clockwise direction due to that force. For WP, it will also move to the clockwise direction, but for this one, it will move to the counterclockwise direction. So that's why I will say torque for WL and WP would be negative, but the torque for P, it should be positive because it's moving to the counterclockwise direction. So then I'll write down this equation. Look at this, I'm writing over here. It should be that first one I'm writing for G into 0, right, plus F into 0. Can you see that picture? Let me allow to again copy this picture, then I think it will be easier for you. Where I keep that part, I keep it over here. Oh god, it's not copied properly. We selected everything. No. All right. So try to understand actually. So f will be 0, or I can draw it again for you for over say this is my ladder, this is my axis, and these are the force. This is actually your force actually G. This is the force of F. This is the force of WL. This is the force of WP, and this is the force of the P, right? And this distance actually X, and this distance should be L by 2, half of this length of ladder. Let's right now calculate the torque. So all right, so now minus WL, this is the force. Come on. This is WL into L by 2 into sine 40 degree minus WP into X into sine 40 degree plus P into L into sine 50 degree equal to the 0. Hello, can you hear me, guys?
Yes, sir.
Yes, sir.
All right, do you understand this part? How I write down this thing?
জি স্যার বুঝছি।
All right, fine. So now then you can find out this thing actually, because I know the value of everything. So I know the WL, which is given actually. The weight of this ladder is 355. Length of this ladder is 8. So L by 2 would be 4. You know that weight of this person is 875, and the person actually that at a distance x is given, which is 6.3 meter, and that force at a distance L, which is the 8 meter. If you plug in those values, you'll be able to find out, or you can solve the P from here. I just jump over here because that the Pu should be 727.13 Newton. This is the value of the P. If I know the P, then I will be able to find out also the F, because P actually the F, right? We write them actually over here. So P would be equal to that F actually. So then I will be able to write P would be F would be 727.13 Newton. So this would be the answer of this question. Do you understand this one?
জিটা কেমনে বের করব?
Which G? G I already find out. This
ও
one.
ওকে।
How many minutes do I have? 5 minutes.
Yes, sir.
ইয়েস স্যার।
That's fine. So that's all. I think I need one or two more problem actually have to solve from here. If I get the time, because we are going to meet after this, because this is the last class before the vacation, right? And we are going to meet probably
Yes, sir.
in when we have a class with you. Is there any more online class? There is a physical class, as far I know. That should be 30 April actually. Is there any more class before that with you? Probably not, because
No, sir.
university is going to open actually 26. So we don't have any class before that. So we are going to meet actually that 30 April actually. All right. So what I'm going to do, if I get the time actually, I will try to solve one or two more problems actually over there, and I'll also uploaded this video actually into the YouTube channel. If you want, you can access those from there actually. That's it. And you have a quiz today, right? Do you know you have a quiz today?
Yes, sir.
Yes, sir.
So at 11 a.m.
স্যার
Sorry, p.m. Hello.
কুইজটা কি স্যার 11টায় হবে না স্যার?
Yes, 11 p.m. actually. Should be 11 p.m.
Yes, sir.
All right. One thing, guys. Give your attendance first. Give your attendance first. Write down just your ID into the chat box.
Yes, sir.
Yes, Tamim. Tamim, do you have any question? You raise your hand.
স্যার কুইজে কোন কোন টপিকগুলো ইনক্লুডেড থাকবে
So
মানে কোন
this
কোন টপিকের উপর কুইজ হবে
only the linear momentum and collision.
So, sir, entire chapter 9.
Yeah, enter chapter 9 exactly. All right. So do you have any question? Is there any more question from you guys?
No, sir.
No, sir.
All right, guys. Then thank you very much, and Eid Mubarak to all of you. See you in the after the vacation. Enjoy your time, and one more thing. Actually, be careful about your guys because right now weather condition is too bad. All right, guys. See you in the after the vacation. Thank you very much.
Assalamu alaikum, sir.
Wassalam.
Assalamu alaikum, sir.
Wassalam.
আসসালামু আলাইকুম স্যার।